Okay, today we start the first chapter of the second semester. Now, second semester, many of the topics are not going to be reviewed like they were in the first semester. So that's why second semester is going to be tougher. Why, did you think it was going to get easier? So we start with conic sections. Now, I will tell you that based on the past 25 years, for some reason, this is not a good chapter. I don't know why students don't like conic sections. It's like one of my favorites.
I don't even know what the
Oh gosh. Did we or did we not watch Donald Duck in Mathematics Class?
We did not. We should watch it.
And didn't they talk about the conic sections?
I'll be perfect rectangle.
No, yeah, but I'm not talking about that.
The golden
I'm
rectangle.
talking about the conic sections. It was kind of toward the end of the movie.
This seat feels weird. Like, you're surrounded by everyone. Oh yeah.
So next chapter, I don't even have to
Oh, you
make
just
copies for you because you can have your iPad except mom.
and both.
Oh yeah, I gotta make 2 copies.
Well,
No, you guys just go to the site and print it on your own.
Yeah, what doesn't need it, bro?
hey, I don't know that I know his knowledge. I feel like it's
I'm in his seat, so I'm
Okay, what is a conic section?
a cone.
It's a section of a cone. Now here's a cone. I'm sure you've seen this before. You're both last year, and any pre-calculus or algebra 2 book is going to have this in it. Okay? So you have a right circular cone. Now just imagine it extending forever. If I take a plane and intersect it with this cone, the intersection is going to be called a conic section. So what would happen if I take a plane and make it parallel to the base here? Cut it right there. What is the intersection going to be? A circle. Look, right there. So you cut it, and then, ooh, you get a circle.
Circle is an
There's no eclipse.
Why isn't it an apple?
It's a circle. It's a perfect circle. Look at that. The picture over there. It's a perfect circle because it's a cone.
Wait, oh, you cut it this way?
Is there
Parallel to the
perfect?
base.
Okay.
Parallel to the base. Now, what happens if you don't make it parallel to the base? Like, let's say the plane is like that.
Oval.
Oh,
Then
yeah,
you get
circle.
an ellipse.
Ellipse.
Not an eclipse. It's called ellipse. We just did it. Remember when we did polar? You had to graph the ellipse. Did I say eclipse? Did I say oval? No, it's an ellipse. And Donald Duck in Mathematics Class. What was the uses of the ellipse?
Music.
They had it on the. Why did I even show you that thing?
Orbits.
Yes, orbits of the planet. When a planet goes around the sun, the shape of the orbit is an ellipse. And you guys in physics should know this, right?
No.
Kepler's laws
Maybe
in
80.
physics. Okay, now imagine that you have 2 cones, and they're nose to nose like this, and they both extend forever in both directions. What if I take a plane now and intersect it, but it's going to be parallel to this edge right here? So like boom, right there. Cut the plane right there. What's the intersection going to be?
Hyperbola.
No, parabola. Because look, if you make it parallel, then it's not going to intersect the upper part, right? So the only intersection is right there. So that would be this one right here. See how this is parallel to that? So if I cut it with a plane, the intersection is a parabola. Parabola.
Wow.
Okay, now what if I take a line that's not parallel to the edge of the cone there? Like this. What if it's like this? See, then you're going to have one intersection here, but then it's going to touch up here. Then you get another one. So since you have 2 branches, it's going to be a hyperbola. So like if it's not parallel, it's going to be this one here. Hyperbola. But how can I tell the hyperbola from the parabola? Because a hyperbola has two. Parabola only one. These are called the conic sections because they're sections of a cone. Now, there are other conic sections as well. Like what happens if I take the plane and intersect it like right along this edge here? What's the intersection going to be?
Rectangle.
No, a line. A line is a conic section. What if I take this plane and intersect it like right there?
A point.
You're going to get a point. A point is also a conic section. Okay, but in this chapter, we're just going to do circle, ellipse, parabola, hyperbola. That's all we're doing, because I'm assuming we know how to deal with points and lines. Although I don't know. Okay, now what does an equation of a conic section look like? Well, the general second degree equation, you guys know what I mean when I say second degree? The highest power is 2. So this is the general second degree equation. Any second degree equation, the graph of it is always going to be a conic section. Like for example, what would happen if A, B, and C are all 0 and you only end up with that? That's a line. Now last year, you guys only studied conic sections without this xy term, right? Now let's just take it away. What if you didn't have this xy term?
Circle.
Let's review what we learned last year. What would happen if A and C are equal?
Circle.
You get a circle, right? What happens if A or C is 0? Just one of them is 0 like that. You just have that. And you get a parabola. What would happen if A and C are the same sign but different?
Ellipse.
Then you get an ellipse. And what would happen if A and C are opposite in sign?
Hyperbola.
You get the hyperbola. We learned this last year, right?
Kind of.
And then in the first quarter, I made you graph some conic sections with that xy term. Remember? What does it? How can you say no, Ma? We just did it a few months ago. This has the effect of rotating the graph. So instead of getting an ellipse where the major axis is horizontal, you get an ellipse where the major axis is like up at an angle. Remember graphing that on your homework? So instead of a parabola where the axis of symmetry is vertical or horizontal, you get a parabola at an angle. So that's what this xy term does. It rotates the conic section. So last year, you guys did it without this xy term. Now we're going to put it in. See what happens. Just give up already on the first day. Okay, so we're going to do this in a I'm going to make it easy for you. We're going to study circles today, then we're going to do parabola. Then we're going to do ellipse, and then we're going to do hyperbola. But on the test, it's all going to be mixed up, you know. Okay, so today we start with a circle. First of all, what is the definition of a circle? In fact, here, true or false? The definition of a circle is this. It's the set of points that are equidistant from a given point.
No. True.
That's false.
Oh, man.
Because we don't know what dimension you're talking about. Because if you're in 3 dimensions, what's the set of points that are
Sphere.
equidistant from a given point? It would be a sphere. What if you're in 4 dimensions? It would be a hypersphere. What if you're in 1 dimension?
Point.
Circle.
Nothing.
Oh, God.
Doesn't exist.
Okay, in physics, aren't you guys good at 1 dimension? Particle moving on a number line? You guys always talk about the velocity and acceleration, right? Okay, here's a given point. What are the set of points that are 2 units from that point? But it can only be on this line.
Absolute balance.
No, wouldn't it be this point and that point? It would be 2 points.
Absolute balance.
But in 2 dimensions, what's the set of points that are equidistant from a given point? In 2 dimensions. That would be a circle. So that's why the definition of a circle is the set of points in a plane that are equidistant from a given point. You have to say in a plane, otherwise it could be lots of different things. Especially since, you know, 2 chapters from now, we're going to start learning about 3-dimensional and 4-dimensional and higher dimensional things. What's going to happen then? All hell is going to break loose. Okay, now, you're gonna have to learn how to derive equations of conic sections. Because what's gonna happen on the test, I'm gonna describe something. What is the set of points that are like twice as far from here as from there? You're gonna have no idea what it is, so you're gonna have to set it up and then complete the square and figure out what it is. Okay, so here's the plane. Let's say that the chalkboard is the Cartesian plane. What's the set of points in the Cartesian plane that are equidistant from a given point? Now, how do we want to label this given point?
G.
How did we do it last year?
X, Y.
HK,
Oh,
because that represents the center of the circle, right? So what are the set of points in this plane that are equidistant from this given point? Here's a representative point. How do I label that?
X, Y.
X, Y, no, just X, Y. And we want this distance to always be R, because that's the radius of the circle, right? The set of points that are R units from this point, is a circle. Now, how do we get the equation? How do we derive the equation of the circle? Yeah, the distance between here and here is always R. So we're going to have to use the distance formula. You're going to use the distance formula multiple times. So if you don't have it memorized by now, you better have it memorized. So how do you find the distance between 2 points? The square root of x minus the difference of the x's squared plus the difference of the y squared. That's equal to R. This is the equation of a circle, right there. But then we simplify it. Square both sides, and you get x minus h squared plus y minus k squared equals R squared. And there you go. This is called the standard form of a circle. Now, in this class, you got to know the difference between standard form and general form. Standard form is the useful form. See how useful this is? Because if you write it in this form, you know the center is going to be at HK, and the radius is R. That's standard form, useful form. General form means you make one side 0 and you just throw everything else on the other side. That's general form. It's not useful. Okay, so you got to know the distance formula, but you also better know this distance. Remember this one? You have to know this on the final as well. What is this formula used for? Yeah, this is the distance between a point and a line. You got to know that for this chapter as well. Put that in the tool belt. Okay, so what kind of problems are you going to see on tonight's homework? Okay, now you have some review ones from last year, but then they get quite difficult quite quickly. Okay, 2x squared plus 2y squared plus 3x plus 4y minus 1 equals 0. How do I know this is a circle?
Same.
Because A and C are equal. Anyway, we're studying circles. Everything on this worksheet are circles, okay? That's all I know. Find the center and the radius of this circle. How do I figure out the center and the radius of that circle? Yeah, you want to put it in standard form. See, this is called general form. See how one side is 0, throw everything else on the other side? It doesn't help you. But if you want to find the center and the radius, you put it in standard form. So we need to complete the square. What's the first thing I should do?
Move the 1 over.
Well, the first thing I would do is divide everything by 2. Okay, and then you put all the x's together. Then you leave a space. Put all the y's together. Throw the number on the other side. But I divided by 2 first. What do I have to add right there to make a perfect square? You take half of that number, and then you square it. 9/16, right? Half of 3 halves is 3/4 squared is 9/16. What about right there? Take half of that number and square it. 1. But if you add that and that, make sure you add it to both sides now. Because otherwise it's not the same equation. Hey, this is a perfect square. X plus 3/4 squared. Hey, that's a perfect square. Y plus 1 squared. Hey, that's a number. Make the least common denominator and you get 33 over 16. So therefore, the center of this circle is at the point negative 3/4, negative 1, and the radius is root 33 over 4. Now this is the kind of problem you had last year, yeah? You think you're going to have this on the quiz and test? Well, it might be on the quiz, but then I wouldn't put numbers. Okay, let's leave that formula up there because maybe we might use it on the next problem. So I'm not going to ask you to draw any graphs, okay? Because that you did this last year. I'm going to describe a conic section. You have to write the equation of it. That shows more insight. Okay, write the equation of a circle that has center. Give me a number.
2, 0.
Give me some coordinates.
0, 1,
2, comma,
0,
1.
0.
So creative. And it is tangent to the line 3x minus 4y
0.
minus 5 equals 0. Let's make up something. Write the equation of the circle now. If you want to write in the equation of a circle, what are the two things you need?
Distance.
You need the center. Hey, I know the center. And the radius. Now, if you know the center of the circle, you can write over half the equation already, right? X minus 2 squared plus y minus 1 squared equals radius squared, right? So if I could just figure out the radius of the circle, the problem's done. Now, whenever, come on, you were taught this in geometry, SAT, right? This is on the cheat sheet. Whenever you have a tangent line to a circle, you always draw the radius to the point of tangency because it makes the right angle like that, right? So how in the world can I figure out the radius of the circle? It's the distance between this point and that line. That's right. So that's when you use that formula. So the distance between this point and this line, remember, this is A, B, and C. This is x1 and y1. Just plug and chug. So the distance is absolute value of 3 times 2 minus 4 times 1 minus 5 all over the square root of 3 squared plus negative 4 squared. Which is, so this is 6 minus 4 minus 5. Negative 3, but then you got to absolute value it. Why do we need to absolute value it? Because distance cannot be negative. So 3 over 5. 3, 4, 5. So the radius is 3/5. So what number do I put in? 9 25ths. Box that. That's your answer. Yeah. Yes. In fact, I'm pretty sure you're going to use this formula at least twice on tonight's homework. This formula has to be part of you. Just like the regular distance formula, even though some of you, maybe the regular distance formula is not part of you yet. Okay, now the next example, this is the last example I'm going to do. This is the one, this problem is going to be on the quiz. This is number 3 on tonight's homework, by the way. If I give you 3 non-collinear points, like this, how many circles go through these 3 points in the Cartesian plane?
2.
1. There's exactly 1 circle that passes through 3 non-collinear points. We learned this in geometry. In fact, isn't that one of your compass and straight edge constructions? Yes or no, in geometry you have to do constructions with a compass and a straight edge. This is one of them. If you're given 3 non-collinear points, draw the circle that passes through those 3 points. Yes, you did it, but you just forgot. Now, we already learned to do this in the first quarter. We did this. If you think of these 3 points as forming a a triangle, what circle is this that circumscribes it? What is this point called?
S.
What is the center of the circumscribed circle called?
Radius.
The circumcenter. Does that even sound familiar?
Yeah.
What were the 3 things we learned when you have a triangle?
Euler's
And centroid. And those 3 points all lie on a line called Euler's line.
See, I was close.
So, did we learn how to find the circumcenter? Yes, we did this in the first quarter. It's the intersection of the
Midpoint.
perpendicular bisectors of the sides. Okay, if you have a triangle, how many perpendicular bisectors of the sides does it have?
3.
3. But you only have to do 2, right? So like say this side, you find the midpoint, then make a line that's perpendicular to it. That goes through the center. Then you take another side, find the midpoint. You guys know the midpoint formula, right? Then you make the slope perpendicular. Oh, that goes through the center. The intersection of those 2 lines is the circumcenter. We learned this in the first quarter. You guys are looking like, Now, I'm not going to do this method because we did this in the first quarter. Now, if you want to do this method when you do number 3 on tonight's homework, fine. It doesn't take that long. However, I'm going to teach you a better way. I think it's more efficient. Okay, so suppose I give you three non-collinear, and by the way, why do the 3 points have to be non-collinear? Because if 3 points lie on a straight line, how the heck are you going to make a circle? You cannot, because a circle is not straight.
Make the middle one.
That's why they have to be non-collinear. Okay, so here, this is how I write problems. Okay, so what I do is, if I want to make the answer come out nice, I figure out what the center is going to be before I start. So let's say like 2, 1. Yeah, this is how I write problems. This is how I make the answer come out nice. And then I just think, okay, what do I want the radius to be? So then I go like this, okay. 8, 1, 7, 4, 4, 7. Those are the 3 non-collinear points. Okay, so this is like number 3 in tonight's one. Let's erase that out. Write the equation of the circle that passes through those 3 points. Okay, yes, you can do the circumcenter way, but I'm not going to do that. I'm not going to do it. I'm going to show you this other way, and believe me, the reason I'm showing it to you is because it's faster. But you got to practice to get past that. Instead of using the circumcenter method, the perpendicular bisectors of the sides, I'm going to use the general form of a circle. This is the general equation of a circle, which is in your notes. Yeah, but Mr. Parker, I thought there was an A here and here. Yeah, there is, but if these two numbers are the same, can't you just divide everything by A to make the coefficients of x squared and y squared 1? Yeah, which means there's only 3 letters to find. Yeah, but there's 3 points. So what do you think I'm going to do with those 3 points? Plug it in, that's right. So all you have to do is take these 3 points, plug it into this equation, and then solve 3 equations, 3 variables. It's quite simple. Either way, you're going to have to do work, okay? This is much faster. Now watch what I do to save time, watch. I'm going to plug in 10 for x and 2 for y. Watch what I do. 10b plus 2e plus f equal negative 104. What? Well, if I plug in 10 here and 2 there, isn't that 100 plus 4? What is 100 plus 4? Yeah, you move it on the other side already. Because isn't this the way you're used to saying 3 equations, 3 variables? Okay, plug in the next one. 9p plus 5e plus f equals, okay, if I plug in 9 here and 5 there, what? What's 81 plus 25? 106, move it to the other side, negative 106. Okay, that's too difficult for you to just do it and then do this on the next step. I'm trying to save you time here. Okay, then plug in the last point. 6e plus 8e plus f equal negative 100. Boom! If you cannot add numbers up, then you're in trouble with this chapter. Because you got to be able to do arithmetic and algebra. That's the key to this chapter. Basically, again, we're studying analytic geometry. Solving geometry problems using algebra. I already told you guys about it. Okay, now, all I have to do is solve these 3 equations, 3 variables, and I'm done. Okay. You don't have enough practice? Okay, now, in Algebra 2, okay, when you come out of Algebra 1, you're supposed to be experts at solving 2 equations, 2 variables, right? When you come out of Algebra 2, you should be experts at solving 3 equations, 3 variables. When you come out of pre-calculus, you should be experts at solving n equations and variables. Believe me, 2 chapters from now, when we finish that, you're going to be able to solve 100 equations, 100 variables.
Yeah.
Of course, you're going to get to use your calculator, but you're going to be able
Oh.
to. Okay, first step. Let's review Algebra 2. The first step is to eliminate one of the variables. But look, since the coefficients of f are all 1, if you just subtract one equation from the other, the f's are gone. Okay, so here, you want to be babied and coddled there. Let's call this equation 1, 2, and 3. What's 1 minus 2? Go.
Negative 1.
Minus 3e equals 2. See how we eliminated one of the variables? Now you have to involve equation 3. So either go 1 minus 3 or 2 minus 3, it doesn't matter. Okay, 2 minus 3 because they're next to each other, less chance of making mistakes, right? Okay, subtract. 3b minus 3e equals negative 6. See how? Now we got two equations, two variables. Now it's only algebra 1. Now you eliminate one of these variables, and I think E would be the best because the coefficients are the same. So if you just subtract the two equations, you get 2E equals 8. D equals negative 4. See how this is ridiculous? Once you figure out what D is, plug it back into one of these. Probably this one is the easiest. So D is negative 4. That means negative 3E equals 6. E equals
2.
negative 2. And then once you figure out D, you plug it back into one of these over here. Which one looks the bestest? It doesn't matter. Negative 4, negative 2. So F comes out to? This is negative 24. That's negative 16. So that's negative 40. So if I add 40, F is negative 60.
Big.
Come on. So the equation of this circle, therefore, is x squared plus y squared minus 4x minus 2y minus 60 equals 0. Boom, that's the equation of the circle. If it doesn't say what form to leave it in, just leave it in that form, right? That's the equation of a circle. However, on the quiz, I'm going to ask you, find the center and radius of the circle. So you got to complete the square. So put all the x's together, leave a space. Put all the y's together, leave a space. Throw the number on this side. What do I need to add there? 4. Take half of that and square it. What about here? 1, but I actually added 4 plus 1, which is 5. So therefore, x minus 2 squared plus y minus 1 squared equals 65. So the center is at? Right, remember I started with 2, 1? And the radius is root 65.
Oh.
Now, remember I went 2, 1. You know why I like 65? Because there's because I like to use 8 and 1 and 4 and 7 because what is 8 squared plus 1 squared? 65. But what is 7 squared plus 4 squared?
65.
It's also 65. See, that's why I like to use 65 because there's two different pairs of numbers where that squared plus that squared will give you this squared. 8 and 1 and 7 and 4. That's why I like to use them. But I also have other ones in my pocket too. I'm not going to tell you. Because you know what most teachers do? Most teachers just do the 3, 4, 5 triangle and the radius comes out 5, right? So they just go, okay, from the center, go 4 right, 3 up, 3 right, 4 up, 3 left, 4 up. But that's weak. Because to make 25, it's just 3 and 4. That's it. But with 65, you got 8 and 1 and 7 and 4. That's how I write problems. And like I said, I have others in my pocket waiting for you and for the quiz and test. Can you do this?
Yeah.
Okay, that's all you gotta do. So this is one of the 3 problems on Friday's quiz now. I didn't put PCH. PCH quiz Friday. Or is it Thursday? No, it's Friday. PCH quiz Friday.
Tuesday.
So I think you're gonna have 2 circle problems and 1 parabola problem. That's what I did. So tomorrow we study. You guys even remember what the definition of a parabola is? A U-shaped thing.
Half of hyperbole.
Equals x squared.
It's a set of points in a plane equidistant from a given point and a given line. The point is called the focus and the line is called the directrix.
I remember that.
Okay. That's okay. Just be here tomorrow then. Or read. How about this? How about this semester? You actually read the notes and look at the examples. Make a New Year's resolution.
Mine is to come in every day.
Mine was to come in late to school.
No, come in.
Mine was to come in 7. Come in 7:40 every day.
No. We're waiting.
Okay, we're done. You have 10 minutes left.
I go use the bathroom.
Okay, if you want to know what you got on your final and what the curved score is, I raised the average the last 2 years was 81, yeah? This year, no, it was 78. This year it was 81.3.
So what curve?
So last year they actually got theirs raised to the .666 power. This year, it got raised to the 0.7 power.
Dang it, fool!